Welcome you all students for our digital class, Standard 9 Science and Technology, lesson number 4, Measurement of Matter, video number 2. In our previous video, we have studied about what is Dalton's atomic theory, how are the compounds formed, what are the molecular formulae, law of conservation of matter, atom, mass of an atom, how element is represented in chemistry, IUPAC naming system, molecules of elements and compound. Now let us start with our next part of the lesson. Okay, now students, we have studied about how molecules of elements and compounds are formed. We have studied about the symbols. Then we have studied about the atoms. Now here we are going to study about how molecular mass is calculated and the concept of mole. The molecular mass of a substance is the sum of atomic masses of all the atoms in the single molecule of that substance. So underline this sentence, very important sentence. It says that the molecular mass of a substance is the sum of all the atomic masses. Like suppose for example, if we are going to take it as water, so water is the atomic mass of hydrogen and oxygen. So now let us see how we are going to calculate it. First you will write down the name of the molecule. Now in the molecule H2O, which are the two elements? Hydrogen and oxygen. Now what is the atomic mass of hydrogen? 1. What is the atomic mass of oxygen? Hydrogen it is 1. What is the atomic mass of oxygen? 16. Because it is written as O2. In the last video we have seen it is O2. So what is the atomic number of oxygen? It is 8. So 8 2s are 16. So atomic mass of oxygen is 16. Now how many hydrogens are here in H2O? 2. How many oxygens are there? 1. So we will write number of atoms in the molecule H is 2 and oxygen is 1. So 1 multiplied by 2, that is atomic mass multiplied by the number of atoms in the molecule. So 1 multiplied by 2, 16 multiplied by 1. So mass of hydrogen is 2 and oxygen is 16. Now you have to add these two. So what you will get? Molecular mass of hydrogen, water is 18. I hope this is clear to you. Now similarly you can calculate about the atomic mass, the molecular masses of many different compounds. So now here children, on your page number 51, the atomic masses are given: hydrogen 1, oxygen 16, nitrogen 14, carbon 12, potassium 39, sulfur 32, calcium 40, sodium 23, chlorine 35.5, magnesium 24, aluminum 27. Now you have to calculate the molecule with the molecular help of molecular formula, the molecular masses. Like for example, sodium chloride. So what is the atomic mass of sodium? 23. What is the atomic mass of chlorine? 35.5. So sodium chloride will be 23 plus 35.5. Okay. Now I will be sending you a worksheet where all these things will be calculated and given to you, and also you will learn to do it on your own. Now children, you have already seen the molecular masses. Now let us see what is mole. Now suppose if I tell you to weigh tur dal, if I give you 1 kg tur dal or masur dal or chana dal and I tell you to just weigh it, so you can take the weight of that tur dal. But can you count how many tur dal is present in that 10 gram tur dal or 1 kg tur dal? It is not possible for us to go on counting. It depends, very difficult for you to count. Okay. Now what you will do is, you can just take a line, draw it on the paper, a line, and go on pasting the dal, so that you will go on counting. But how much time it is going to take? It is going to take a lot of time. Okay. So we have a very easy method to do this. When elements and compounds, now in the elements and compounds, can you calculate how many salt, how much of salt in 10 grams of salt, how much of salt quantity is there? Can you count it? No, it becomes very difficult. So here the mole concept is introduced. When elements and compounds take part in the chemical reaction, it is their atom and molecules that react with each other, and therefore it is necessary to know the number of their atoms and molecules. However, while carrying out a chemical reaction, it is convenient to measure out these quantities that can be handled instead of counting the numbers of atoms and molecules. The concept of mole is useful for this purpose. Now, what is mole? A mole is that quantity of a substance whose mass in gram is equal to the magnitude to the molecular mass of that substance in Daltons. Okay? Thus, the molecular mass of oxygen is 32, and therefore 32 kg of oxygen is 1 mole of oxygen. The molecular mass of water is 18 Dalton, therefore 18 gram of water make 1 mole of water. So, is it clear to everyone? Now again a new concept, Avogadro's number. The number of molecules in 1 mole of any substance is constant. The Italian scientist Avogadro did fundamental work in this context. Therefore, this number is called as Avogadro's number and is denoted by the symbol n small a. Later, scientists they found out the value of this number, which is equal to 6.022 into 10 raised to 23. Okay. Now, how many moles are there in carbon dioxide? So, how we are going to find it out? Number of moles in the given carbon dioxide is mass of carbon dioxide in grams upon the molecular mass of carbon dioxide. It comes to 1.5 mole. Now, 1 dozen banana, how many bananas are there? 12. Now, suppose if you want to see how many notebooks are there in 1 cross, they are 144. 1 mole of common salt is equal to 6.022 into 10 raised to 23 molecules. So, this is the way how we are going to use the Avogadro's number. Now, can you see in the picture here children? Sodium and chlorine is there. Okay. Sodium has the electronic configuration 281. Sodium has the electronic configuration 281. The atomic number of sodium is 11. The atomic number of chlorine is 17. Now, chlorine requires 1 electron to complete the octet, and sodium, when it will give 1 electron, it will form a sodium ion. So, sodium is giving 1 ion to chlorine and chlorine is accepting 1 ion. Sodium is losing 1 electron and chlorine is accepting 1 electron. See, you can see here children, sodium atom electronic configuration 281. So, it loses 1 electron and it forms a plus. So, the one who gives forms a positive ion, and the one which takes the electron, that is chlorine, is taking the electron to make it 288. So, it becomes a chloride ion. And then Na plus and Cl minus gives you NaCl, that is sodium chloride. So, we come to the concept valency. The number of electrons that an atom of an element gives away or takes up while forming an ionic bond is called valency of that element. So, the valency of sodium is 1 and chlorine is 1, because sodium has given 1 electron and chlorine has taken 1 electron. Now, let us see what are cations and anions. Positively charged ions are called as cations, that is sodium plus, and chlorine negative minus is called as anions. For example, MgCl2 contains Mg2 plus and Cl minus as cation and anion respectively. The electron present in the outermost orbit of an atom are called as valence electrons. See, you can see it here, magnesium atom combines with chlorine to give you magnesium ion. The 2 electrons lost by magnesium atom are gained by chlorine atoms and to produce a magnesium ion and 2 chloride ions. So, magnesium is a cation and chlorine is an anion. See, in this example also you all can see it, calcium atom, oxygen atom. So, calcium ion, okay, and oxide ion is formed. Okay, students. Now, you will complete the following chart in your notebook. Hydrogen atomic number is 1, electronic configuration is 1, valence electrons 1 and valency is 1, because it is going to give 1. Now helium and neon, they are stable elements. They are not taking part in any chemical reaction. Lithium electronic configuration 2, 1 means what is going to be the atomic number of lithium? 3. Number of valence electrons? 1, because 2 and 1. So in the last orbit it is 1, and so it is valency is going to be 1. So accordingly you will complete the whole table. Now sometimes what happens is, under different conditions, the atoms of some elements, they give away or take up different numbers of electrons. In such cases they have more than one valency. So this is called as variable valency. Iron Fe exhibits the variable valency 2 and 3. Therefore iron forms two compounds with chlorine, that is FeCl2 and FeCl3. Okay, ferric and ferrous. Copper also it has variable valency, cuprous and cupric. Mercury also they have two valency, mercurous and mercuric. Iron also has two valency, ferrous and ferric. Okay, now here you can see in this example, hydrogen and oxygen when they combine to form H2O. Hydrogen atoms and oxygen atoms, they combine to form a molecule, hydrogen and water together, that is called as water, and the formula is H2O. Now we have seen about the radicals, the cations and the anions. Here the element which gives the electron is called as the cation, the positively charged, and anion is the negatively charged. So accordingly you will write it Na plus OH negative, K plus OH negative, and again in the worksheet I will be sending you this table also. Compounds with ionic bonds have two constituents. These are the cations, that is the positively charged ions, and the anions, they are negatively charged ions. They take part independently in the chemical reaction and therefore they are called as radicals. Now here the radicals are basics and the radicals are acidic. Generally basic radicals are formed by removal of electrons from the atom of metals such as sodium, copper, Na plus, Cu 2 plus. But there are some exceptions such as NH4 plus. Similarly, the acidic radicals are formed by adding electrons to the atoms of nonmetals such as chlorine, sulfur. But there are some exceptions like MnO4. Now you are going to solve this in your, you are going to write down this in your notebook also. I will be sending it in the worksheet, how to write the simple radicals. There are monoatomic radicals such as sodium, copper, chlorine, means only one electron is given or taken. When a radical is a group of atoms carrying charge such as SO4 2 minus, NH4 plus, it is called as the composite radical. The magnitude of charge on any radical is its valency. Now let us see what is the chemical formula of a compound. The characteristic of a compound formed by ionic bonds is that its molecule has two parts. Now every chemical formula of a compound has two parts. One is a cation and one is a anion. That it is a basic radical and an acidic radical. Both they have the opposite charge, that is the plus charge and the negative charge, positive charge and the negative charge. The force of attraction between them constitutes the ionic bond. The name of the ionic compound contains two words. The first word is the name of the cation and the second is the name of the anion, that is sodium chloride, okay, magnesium chloride, ammonium chloride. In this way, potassium sulfate, in this way it is written. Now let us see how we are going to write it. Now let us see. The formula of a compound such as sodium chloride is written by writing the symbol of a cation at the left hand side and then anion, that is NaCl. How we are going to write sodium chloride? NaCl. The charges are not shown through the number of ion is written as a subscript on the right hand of the symbol of the ion. In the case of composite radical, the number is written as the subscript outside the bracket enclosing its symbol. This number is obtained easily by the method of cross multiplication of the valencies. Now let us see how it is done. To write the symbol of the radical, basic radical is written at the left, Na, and SO4 acidic is written at the right. Now step 2 is you will write the valency below it. Sodium has the valency 1 and SO4 sulfate has the valency 2. Now we are going to cross multiply it. So how the formula will be written? Na2SO4. In order to write the chemical formulae of the compound, it is necessary to know the valency of all the radicals, various radicals. The names and the symbols are given in the next slide. Children, you will learn the next slide by heart. And when I am going to send you the worksheet, I will be sending you some examples which are solved and some you have to do it on your own. Like some compounds are written by me and some you will have to write it on your own, so that you will learn it how to write it properly. So here different radicals are given, basic and the acidic. Hydrogen, sodium, potassium, silver, mercury, cuprous, they all are monoatomic. Cupric, magnesium, calcium, nickel, cobalt, mercuric, manganese, ferrous, stannous, platinum, aluminium, chromium, ferric, gold, stannic, ammonium, they all are polyatomic. Okay, we have studied in our previous slides. Acidic radical, hydride, fluoride, chloride, bromide, iodide and so on. Now when you are going to write the formula of any molecular formula of any compound, you should know the basic radical and you should know the acidic radical. So this table is very important for the 10th standard also. So you will learn it very properly. See that you practice writing. And as I told you, I am going to send you some worksheets where the worksheets will be solved, and some worksheets you have to solve it on your own, where you will learn first the basic radicals and the acidic radicals and then start writing it accordingly. As I said in the first video, same thing here, you will read the lesson, you will watch the videos, and when I am going to take the online lecture, I will be explaining the lesson again. We will take a revision. Okay, so now let us revise what we have done. Molecular mass and the concept of mole, molecular mass, Avogadro's number, valency, variable valency, radicals, chemical formula of compounds, ions and radical, and we have studied about the basic radicals and the acidic radicals. See that you write it down very properly in your notebook, and the answers will be sent to you so that you can learn the answers and write down in their notebooks, in your notebooks. Thank you. Stay home, stay safe.